I had the request to do a problem from chapter 8, section 8.3, number 22 to be specific. And so it was a little bit too much to just try to explain via email to the students, so I thought I'd make a video solution and then post it for all. In this question, they're asking us to do um, a division of two complex numbers, and here they are, 1 and 2 minus 2i. And what they'd like us to do is not use what we would have traditionally done in an algebra class, and that is to multiply top and bottom by the conjugate and simplify. Although that's probably the faster way, their goal right now is to get us to practice in a small setting. Translating into trig and then using the trig to help us out, and it really does help us out in big broad situations. So if that's the case, the first thing that we're being asked to do is it says that we need to first convert the numerator and denominator to trigonometric form. If it says that on your test and you don't put it in trigonometric form but just do it algebraically, you'll receive no points because you didn't follow the instructions. We already have tested you in your algebra skills. We want to make sure your trig skills are good. So let's go convert. If we start to look at 1, we need to convert 1 into its cosine I sine form. Well, no problem. Let's draw it. I think it's always wise to draw the complex number 1. And so I'm going to come in here in blue, and I'm going to mark out a distance here of 1. This is the complex number. Actually, let me get rid of that line. This is the complex number 1. Right? 1 in the real direction. So let's talk about that. We would look at this line. I'll make it in green in order to help ourselves out. Well, what's the magnitude of that green line? That's easily identified because it's going in one direction. So let me move this 1 down here so I can, or actually I'll put it up above. 1, then the magnitude of that green line is 1. And what angle is it at? Well, that's easily identified too. That's 0 degrees. Perfect. We've translated 1. Now let's come in here and let's do the 2 minus 2i. Let's graph that. That would be 2 in the real direction, negative 2 in the imaginary direction, and there's our complex number in the complex plane. So remember the x direction is the real and the y direction is the imaginary. So what do we need to do? Let me draw the line in green again. I need to know the length of that line. No problem. The length of that line, we've been practicing since pre-algebra. The r is equal to the square root of 2 squared plus negative 2 squared. Of course that's what it is. Take a look at the triangle that you get, and that's why I'm saying it's a pre-algebra concept. You're just using the Pythagorean theorem. The r squared, the green line squared, is equal to the x distance plus the y distance. Well, you know what that is. That's 4 plus 4 under there for 8, and you know how that simplifies. That's 2 root 2. And so when we go to translate 2 minus 2i, no problem. Its magnitude is 2 root 2. Now, what angle are we dealing with? Well, maybe you know it right now just from experience, but if you didn't, you would set tangent theta equaling negative 2 over 2 or negative 1. So we know the thetas that give us 1 and negative 1 for tangent. If you do the tan inverse, it's going to tell you negative 45 degrees. Okay, that is true. Now we got to make sure, are we in that quadrant? Well, we are in the 4th quadrant, so we could use negative 45. I'm going to opt to use 315 degrees, but either one would work. In fact, it shouldn't matter as long as you have the right quadrant identified. Notice both are quadrant 4. It is possible to have had a quadrant 2 angle out of that, and so the tan inverse is always going to give us the negative 45. So if I'm in the 2nd quadrant, I have to recognize that as 135. So I'm going to use, I said I wasn't going to do it, but I'm going to use the negative 45 degrees. That might be nice. Or you could use 315. Doesn't matter. So I'm going to go ahead and erase this. And we're going to go back over here. And we're going to plug in our translations. Right, so good stat, or sorry, not stat work, good trig work here. We're doing great. What's 1? 1 is 1 CIS 0 degrees. What's 2 minus 2 root I? That's 2 root 2 CIS negative 45 degrees. And I just wanted to stress that you can use any representation of the angle that you want. It just needs to be a fourth quadrant angle. So we know what to do. We divide those A's out in front and we subtract the angles. And what is 0 minus a negative 45 degrees? Well, it's just 45 degrees. Well, we know about that. So let me keep this 1 over 2 root 2. And let's talk about what the cosine of 45 degrees is. The cosine of 45 degrees is root 2 over 2. And the sine of 45 degrees is also root 2 over 2. So what do we have to do to finish and match the answer in the back of the book? Well, we need to distribute that 1 minus 2, 1 over 2 root 2 to both the first and second term. Well, notice as we do that, the root 2's will cancel. I'll write it out in case it's too much at the same time. There's the first piece. So the only thing that happened here is I brought my root 2, my 1 over 2 root 2 into each one. So now what can happen? My root 2's cancel. And what are we left with? The answer that they have in the back of the book. 1/4 plus 1/4 I. A great way to get that using trig. And again, the trig has other implications, so we really want you to practice with it, even in a realm where you know you can do something different. All right.